Welcome to July 21st LeetCode Challenge. Push dominoes. There are n dominoes in a line. We place each domino vertically upright. In the beginning, we simultaneously push some dominoes, either left or right. After each second, each domino falls from the left. Is falling to the left. Push gets pushed left. The adjacent domino to the left on the left. So when they're falling to the right, push their adjacent dominoes to the right. When a vertical domino has dominoes falling on it from both sides, it stays balanced due to the forces. The purpose of this question is to consider the falling dominoes expends no additional force. For the purpose of this question, I say the domino expends no additional force in falling or has already fallen on dominoes. You're given a string dominoes representing the initial states. So you have a domino index I representing L if the dominoes push to the left. Dominoes at index I equals R for the ith dominoes falling to the right, and lastly we have a dot here which the ith dominoes often push or balanced. Return the string representing the final state. So we have a string of dominoes here. You have basically you have right dot left, which means that the dominoes being pushed the two R's means the two dominoes are being pushed to the right, and then the domino on the left here, this L here means it's pushed to the left. Therefore, the domino in the middle is standing vertically straight. However, afterwards we get the same results because this domino here remains balanced because the two forces right and left do not exert or neutralize each other. We have a drawing here. So, for instance, we have this domino pushed to the left. So every single domino to the left of it will be pushed to the left. If we have no dominoes that are not touched, such that the force is pushed away from it, the dominoes will not be affected. And likewise here for this third domino, and we have dominoes being balanced right here in the middle, so the forces neutralize each other, and therefore we have the result as it is. Let's look at constraints. Yeah, between 1 to 10 to the 5th, and dominoes can be the left, right, or neutral. Alright, when I first read this question, I thought of using a queue. So that's my approach. It's not really the best answer, but it's an answer that I kind of thought of. So let's first put the dominoes into a string, dominoes into a list. So let's call this list equals the list of dominoes. List domino. Yep. And then what we want to do is develop a queue. So we'll call this, I'm going to call it, call it D for DQ. So it's just a double-ended queue. And what I want to do is have a list inside that. Then what do we want to do? So I want to run a for loop to basically enumerate all the dominoes in the direction. So for I and direction, D direction, not direction. And enumerate the dominoes. What I want to do is that I want to find out in what direction they're falling. So if direction is in the set, left or right, left, right, then what we want to do is append that to the queue. So d.append it to the queue, and we want to know the index and the direction and the index. Alright, so basically this is we develop the list of dominoes, and we have assigned a variable d called dq, which takes in the list, and we iterate through the index and the direction of the dominoes using enumerate. Now if the direction is either left or right, what we're going to do is going to append that to our dq, so we know that what direction it's in, being pushed in, and also we know the index where it exists. So first, that's basically it. Next thing I want to do is I'm going to create a while loop. So while D exists, while the DQ exists, we're going to develop a set that's called visited. So basically, we want to know whether we have visited that that index before. And let's see, for the space, for each space for blank and range of the length of Q and D, what we want to do is call this Q, just because it's a little bit easier to remember. So we want to know the direction. We want to know the index as well. Let's call this index. And we're gonna Q dot pop left. We want to take the Q. We want to pop it from the left and take the remaining number off. And we want to assign that both to direction and index. So next we're going to do some if statements here. So if the direction that we have is it's right, then what we want to do, and the index itself plus 1 less than length of the list. Then what we want, and we want to know the list at the index plus 1 is equal to dot. So if the direction is equal to the right and the index plus 1 is less than the length of the list, right, it means within our bounds, and the list of index plus 1 is equal to the dot, then what we want to do is we want to update our visited, right? Update our visited set. So visited at index plus 1 will be reassigned to right, because this is pushing every domino on the right. That's a dot is being pushes onto the right, so we're gonna update the next domino to the right of it to be right. If the index plus 1 is not in visited, else leave it as a dot. So yeah, that's pretty much it for the right. Now we're going to do the same thing for the left. So if the direction is equal to left, and the index plus 1, no, minus 1 actually, because we're going to the left direction, is less than the length of the list, and the list at index, no, the length list at index minus 1 is equal to dot, then what we want to do is we are going to, I should probably fix this. It can't be less than 1. It could be greater or equal to 0, because this is going from the we're going to the left side. So yeah, that makes sense. So we're gonna update visited at index minus 1 to be left if our index minus 1 is not in, why am I having it? Is not in visited, I'll leave it as a dot, or neutral, I should say. Alright, so we have all this to say that we loop through each space or each element in our range of our queue, and then we just make sure that we update we visit each index, and we update the neighboring domino. Next thing we want to do is we need to be able to update the list that we're going. So we're gonna enumerate. We're gonna do another for loop. So for, let's see, need 2 variables. So let's say for the key and value in visited dot items. So you want each item in the visited for key value. If the value is not equal to neutral or dot, then what we want to do is we want to append our queue. Append our key value pair. And then we want to update our list with that. So list at index k with the key with our value. So this is basically using a key value pair for our set, but and at the end of this, we want to return our list joined, because alright, let's see if this works. Well, Q gives this. Let me see that. Alright, yeah. Alright, let's submit it. So, let's see, time complexity, we have a for loop here, so at most n times. We have a while loop here as well, at most n times. So actually it would be big O of 2n, so call it n, big O of n. It's not the best time complexity algorithm, but it's relatively, I guess, easy to follow maybe. Space complexity, it's using a queue, so it'll be big O of constant space. No, big O of n, because most of the list is of size n as well. Let's see, if we had to break this down in terms of approach, I would say that we are using, yeah, we're using the, like we're calculating the force on left side and right side. So yeah, basically, it's a modification of, if you look at the calculated force solution, but using a queue and doing a for loop here. So yeah, that's it for today. It's actually quite a tough one, even though I think size is rated medium, but there you go. Have a great day, guys.